All right, we're recording. So tonight we're going to go over Module 8, Security Operations. Automation and orchestration. So automation can be defined as an automatically controlled operation by a mechanical or electronic device that takes the place of human labor. Cybersecurity automation uses automated processes instead of manual processes to better predict behaviors and execute protections much faster. The advantages are it generates faster protections and detects existing network infections. Also, if you have a small cybersecurity team, it is much nicer. Since I was the only person on our cybersecurity team at my last place of employment, it was absolutely necessary because I was tearing my hair out when we first came in. Data enrichment, enhancing data for a broad and deep cybersecurity analysis. Threat feed combination, enhancement of data enrichment that adds third-party threat feeds for the largest possible picture of both breadth and depth, significantly refines the data used by cybersecurity automation. Now, that can be good and can be bad. Just remember, when you're dealing with third-party anything, it depends on the quality of your third party. Automated malware signature creation. So there are two types of virus signatures. There's a digest of the virus file that is taken and then used for identifying the malware using a hash algorithm. And a sequence of bytes in the malware file is compared against a byte sequence of the file in question. Some armored virus infection techniques include what's called a Swiss cheese infection, a split infection, or a mutation. And those all sound pretty nasty because they are. Automated malware signature creation closely monitors the action of the virus, including any variations generated, to create a signature more quickly and accurately. Which is nice because when you have things like polymorphic viruses that mutate quickly, if you have just a static signature database, you're not going to get any changes that are created. So this is an example of what a Swiss cheese infection looks like. So this one basically has encrypted chunks, which is why they call it Swiss cheese. So it decrypts part of it, and then part 2, part 3, part 4, part 5, and then bops, there's your virus code. And the rest of it's there's all of it there. So it doesn't have, instead of having all of it, your payload all at once, which is what early viruses did, it decrypts everything in chunks. This is a split infection, and you can see how everything is kind of moved around. You have your part A, B, D, C, D, and then your main code body, but everything is mixed up. That is because they want to be able to fool those signature databases and things like that. And also because you can just mix those parts around, and if you do not have good automation or good tools, just that, even though they might be the exact same virus code chunks, would be enough to throw them off. Using automation protocols and standards. So security content automation protocols, or SCAP, is an open standard that enables an automated vulnerability management, measurement, and policy compliance evaluation. SCAP is a suite of selected open standards that perform the following functions: enumerate software flaws, security-related configuration issues, and product names, measure systems to determine the presence of vulnerabilities, provide mechanisms to rank or score the results of these measurements in order to evaluate the impact of the discovered security issues. So you know how we've talked about certain things are considered more critical than others, and that's where those scores come in. SCAP standards. So the left is the standard, and then the description. So there's the common vulnerabilities and exposures, or CVE, vulnerabilities in operating systems and application software, common configuration enumeration, CCE, configuration best practice statements, common platform enumeration, vulnerabilities in operating systems, applications, and hardware devices, common weakness enumeration, CWE, software design flaws that could result in a vulnerability. So they may not necessarily, but they have the possibility to create a vulnerability. Scripting and enhancing software development. Scripting, we've talked about, a script is ideal for automation. It's often argued that scripting languages are specifically developed for automation tasks. The language runtime of a scripting language is usually included in the translation of the operating system on the target system. Enhancing software development, continuous integration delivery and deployment, application program interfaces or API integration, a set of automated tools for connecting software applications deployed in different environments. So there's all sorts of scripting languages, but as security people, you'll see things like Python used a lot, and PowerShell is another one. Do any of you guys have experience with scripting languages? Anyone? Bueller. There we go. Bash, Rust, JavaScript, Python. Yep, there you go. There's quite a few different ones. If you do not have experience with it, it's a really good idea to hit one of those boot camps just for something. I would suggest the two that I'm seeing the most are Python and depending on what you're working with. I've done a whole bunch of programming because I did web pages, so I have a lot of experience. I kind of got thrown into, hey, guess what? You get to learn a new programming language in 5 weeks type stuff. So I've done C#, ASP.NET, Java, JavaScript, just chunks and pieces of different things, SQL. But Python and PowerShell, if you're doing anything with servers and things like that, are very important ones to try. Yeah, Python's one you see a lot in Linux. Rust, yeah, I'm seeing Rust coming up a bunch too. There have been several Humble Bundle things where they have Rust. So keep an eye out for that if you're a Humble Bundle person like I am. If I see one, I'll throw it out there for you guys. So yeah, just think of that in your future schooling. I wish I had taken more scripting languages for automation. PowerShell is one that I know just enough to get in trouble with, but Python and PowerShell are ones that I would like more experience with. Continuous integration and continuous deployment and continuous development. So this is your kind of your flow chart here. So manual plan, code, build, manual plan, manual code, automated build, automated test unit. And then in your staging environment, you have your automated section here, bring it up, test environment, and then integration test. Then in your production, you have deploy and monitor, which are automated. And as you can see, you start manual, and then everything else is automated in a lot of this. And then you drop down here, integration tests, system integration tests, user acceptance tests, load tests, performance tests, and if there's like any software tests and things like that. Yes, programming is fun, and I like that. When the program, especially when the code works, when it doesn't work, or if you're having to fix someone else's mistakes, I'll give you an example. The person that I took over stuff from did not want to learn a lot of the new programming techniques. So I was having to pick up after someone who did 10, 15, 20-year-old programming techniques and was a terrible speller. So there were several objects and things like that I was like, why won't this work? And I went and looked and I'm like, oh, he spelled this wrong, or and it was just a mess. And it just made me want to, yeah, exactly. It is an absolute cringe. It made me just want to face plant. And there were several times, and this is why peer review is also important, but there were several times when I would stare at stuff for hours and I would just want to throw everything across the room when I realized that some little tiny piece of referenced code had a misspell. It made me just infuriated. And unfortunately, at the time, I did not have anybody that could even peer review for me because there was no one else in the department that even knew the language. So it was a lot of fun and it made me want to pull my hair out. So that's why I always say, if you have people that build your own network, and if you have people that know this stuff, build your own network of peer reviewers, because it is important. Yeah, coding boot camps. AI is a good tool for peer reviewing. That is something that I have really enjoyed seeing. Is AI can pick out some of that stuff and go, "Hey, did you mean to do this?" So it does have some really good applications when it comes to coding. Okay. Automated software development processes. So we'll start with process name, then description, advantage, and explanation. So there's continuous integration. Developers merge their changes back to the main branch of code as often as possible, even several times each day. The advantage: changes are validated by creating a build and running automated tests against it so that any problems can easily be identified as coming from a smaller segment of code. Explanation: continuously integrating changes from different developers prevents surprises on release day at the end of the project when all changes are merged. Continuous delivery, CD or CDE. Developers automatically deploy all code changes to a testing and or production environment after the source code has been compiled, what's called the building stage. An extension of continuous integration. It allows application deployment more quickly and easily while making troubleshooting easier as small batches of code are released. So that way you don't have like, I'll just read the explanation here. Software can be released on daily or weekly basis on business requirements. So that way you don't have like this massive code update only to find out, oh, we have a serious problem. And then having to go back and redo this huge chunk of coding. Instead, you have small batches of coding that you can instead work through, which is a little bit easier to manage than if you're having to do these massive chunks at a time. And then continuous deployment. Every change that passes all stages of the production pipeline is immediately released to customers. No human intervention is needed. Only a failed test will prevent a new change to be deployed to production. An excellent way to accelerate the feedback loop with customers and take pressure off developers because there's not a single release day. Not sure how I feel about that one. It just depends on what you're doing, because sometimes releasing things straight out to production can be kind of a pain. Workflow orchestration. So workflow orchestration involves automating and combining many individual tasks and processes. Security orchestration, automation, and response, or SOAR, is a combination of software programs and tools that allow organizations to synthesize and automate a range of security operations, threat intelligence, and incident response in a single platform. can automatically and immediately block the IP address of a computer attempting to brute force a login. AI, which we've just talked about, may be defined as technology that imitates human abilities. Then there's machine learning, teaching a technology device to learn by itself without continual instructions of a computer programmer. A neural network is a form of machine learning that attempts to mimic the human brain through a set of algorithms. Deep learning refers to the depth of layers in a neural network. A neural network that consists of more than 3 layers is considered a deep learning algorithm. All right, so these are the different areas in which AI cybersecurity is used. Network security, which shouldn't surprise anybody, is 75%. And as you can see, it drops down from there. Data security, endpoint security, identity and access security, which honestly I thought was going to be higher. Application security, cloud security, and to no one else's surprise, IoT security is on the bottom. Risk of AI in cybersecurity. So security of the machine learning algorithms. Threat actors could attack, compromise vulnerabilities, and then alter the algorithms to ignore the attacks. So just like with any sort of programming, that garbage in, garbage out thing, you know, when you teach something to learn, if you teach it on faulty algorithms, or if someone comes in and changes them, then it will come out with bad stuff on the other end. Tainted training data for machine learning. This, so far, from what I've seen, has been the worst problem. Attackers can cloak themselves by attempting to alter the training data used by machine learning to produce false negatives. And not just that, as far as tainted training, you also have to think of our own inherent biases that we don't even realize till we actually program them in. And that has also been an issue that most of us didn't even realize was there until it started popping up in the products on the end product. Final risk is that threat actors themselves will turn to using AI for attacks to circumvent defenses. Of course they will. Any sort of tool that will make things easier and faster for them can and will be used, because that's just how it works. All right. Which of the following is not correct about data enrichment? It is the enhancement of data for cybersecurity analysis. It includes expanding data sources from a single organization and then combining that with similar data from other organizations. It is both broad and deep. It is identical to threat feed combination. Just take a stab. Stab it. We got 2 people. Come on, you guys can do it. Okay. And there's the explanation there. I'll leave that up. Thank you. An early explanation for COPE. Very nice. They just had to throw another one right in there, which is an open standard that enables an automated vulnerability management, measurement, and policy compliance evaluation. Yeah, I was surprised it was back to back too. I was going to say, I don't think any of the other ones actually have acronyms to anything viable, so. All right, threat hunting. Threat hunting is emergent activity that combines a proactive, repetitive, iterative, and predominantly human instead of automated identification of cyber invasion to an IT network or endpoints. Okay, so when they talk about instead of automated, it's because this is when you take the human approach, because sometimes it's better to have the human eye on some things. Sometimes it's pretty easy to fool automated things, and humans are surprisingly good at picking out patterns. That's just how we are. That's how we've been through years of evolution. So sometimes it's better to take automation out of there and have someone take a look at things just in case. So results of successful work performed by a threat hunter: you reduce the attack surface area, bundling critical assets, and you improve detection capabilities. Plus, if you have some people are just really good at threat hunting, and the more experience you have, the faster you become. It's that we see patterns. Personally, when I look at it, it's just kind of like doing a puzzle. So, and some people just love puzzles. They love seeking things out. They like seeing patterns. They like looking at overarching patterns. And there are certain leaps of logic that machines cannot make that humans can, because we have that creativity. Okay, security roles. So there's title, role, goal, task, driving force, and time frame. So an incident responder is what's considered reactive. You secure the environment after the alarm has been raised, minimize impact of the attack on the organization through a formal process. Your business continuity plans are the driving force for this, and immediate is your time frame on this. So these are the people that work with your, depending on how bad the incident is. I was considered an incident responder team leader, and I dispatched people and worked with them in order to make sure things did not progress to a legal level or anything like that. But I looked at our business continuity plans, our policies and procedures, and made sure that we did not have anything that reached the oops, the government's going to be angry type levels. And I'm happy to say that never happened while I was on staff. So that's the whole point, is you're there to get out and get there as soon as possible. You work with law enforcement a lot of times. Since I had a law enforcement background, that really helped with me. And I had a digital forensics background, so that also helped. Penetration testers are proactive. You secure the environment through controlled offensive exercises, mimic actions of threat actors to test and validate security posture. You uncover vulnerabilities, and the reason they say soon instead of immediate is you go out and say, I like to think of these as you break it to fix it. So you go out and say, hey, look what we found. This is how you can, this is the problem. These are the possible solutions to that problem. So it takes a little bit of planning to fix those vulnerabilities, so you can't necessarily be immediate. And then there's a threat hunter, which is also proactive. You identify suspicious activity before the alarm has been raised. You seek evidence of malicious behavior and prevent infections from spreading. So the longer time frame on these, that's because you're actually out looking at the long-term. It's more, instead of looking at something after the fact, you're trying to look at things before they happen, and you're trying to look at things that might possibly trigger future vulnerabilities and things like that. Does that make sense? Okay. I've had the most experience as an incident responder. I have done all three types of this. They're all really fun, but because of my background, I'm really good as an incident responder team leader. So yeah, threat hunting it's a lot of fun. It takes somebody that, if you like puzzles, incident responder, if you're just the responder, can be really stressful if that's all you do is just respond to incidents. But since I was the one that was in charge and did everything before that as well, it wasn't that bad. I was the one that also made all the policies and everything too. So I'm really enjoy that part of it, which is, I guess most people don't enjoy that, but I do. Okay, pyramid of pain. All right. So I've never seen it called that, but I do enjoy that. I'm probably going to have to steal that slide. All right. So the tip, because of course, those are the smallest group of things. That's your tough, challenging, annoying, simple, easy, and trivial. So hash values. It's funny that they say trivial because those can be difficult, but in this pyramid, it would be a little bit, they're not as difficult as the rest of them are. Okay, levels of threat hunting. All right, so the threat hunting level, the people who do it, the processes, and the tools. So we'll start here on the left, the initial level 1. So existing SOC personnel, you know what they're talking about when they say SOC. It's their, it's their SysOps center. I can't remember exactly what SOC stands for, but basically it's your system. I think it is just Systems Operations Center. I think that's what it stands for. I've seen other people throw different things in there, but I think that's what it originally stood for. Ad hoc hunts with little data collection, standard SOC reactive tools with little automation. Then there's managed, which is level 2, threat hunting performed by a volunteer, uses basic threat feeds with IOC, hunts only occasionally, searching for text strings and automatic matching of IOCs. Then there's defined, or level 3. This is a dedicated threat hunter, formal hunting process that occurs regularly with data collected from key areas. They use a lot of statistical analysis techniques. Then there's quantitatively managed, which is level 4. This is a SOC analyst rotated into threat hunting team. Hunts occur frequently with moderate data collection, and they have all sorts of specialty dashboards that they use. Then there's the optimized level 5, threat hunting teams integrated across SOC with proper resource integration into the process. Hunts occur continuously and data shared across security community. This takes advantage of machine learning. So they not only have they have everything that you see up there, but they also have your dashboards and your machine learning tools. So those are the big guys that everyone else goes to for help. So our threat hunting processes and tactics: select the attack model, profiling threat actors and activities, identifying who the threat actors are and how they function. So when you're hunting a script kiddie, it will vary very, very much from if you're going after someone that you think is a state actor. Identify the most concerning threats, attack vectors, a path by which the threat actor can gain access. So what I looked for when I did this was I would look for the most concerning security holes that they could pivot from the most easily to areas that could get them more access. Create a calendar, generate basically you don't want to go on forever and ever if you're doing something like this. You can if you're doing certain projects, but it's better to break it out into this week I'm going to do this week I'm going to do that, so that you have a certain amount of accountability for your teams. Generate a hypothesis, just like if you're in science classes and things like that. So hypothesis, tentative assumption that is made and will be tested to determine if it's valid. So very simplistically, I see that this person has attached an unpatched IoT device to our network. My hypothesis is this device will be attacked and used as a pivot device, things like that. And that's just a super basic example. Investigate the hypothesis, searching, clustering, grouping, stack counting, and machine learning. These tools allow for an investigation of how the malware functions, executable process analysis. Various threat intelligence feeds can be combined for integrated intelligence, and then you act on the results. Now, depending on what type of threat hunting you're doing, sometimes you will have to do like formal reporting and things like that. And then you can act on the results. It just depends on what type of industry you're in. So this is a MITRE attack matrix. This is, as you can see, it's one of those like flow charts, but it gives you an example of how complicated these can be. So you have your reconnaissance, resource development, and initial access. And as you can see, you have your, on your left here, active scanning, gather victim host information, and then they have it all broken out. This is actually a really good example slide. If you guys are having a hard time remembering some of this stuff, it's a great example. And another knowledge check. Which level of threat hunting uses a threat hunting team integrated across the SOC? Manage, quantitatively managed, optimized, defined. Two of those are not in the list. And because they put numbers on them, I would be more likely to remember the numbers than the words. So okay, it looks like everyone has a consensus on what they think. So let's go back to that. There we go. There's the list right there. So we have initial, managed, defined, quant, then optimized. So hunting team integrated across your SOC. That one, as you can see, that one is down there. Yeah, no, it's okay. That's the problem with some of these, especially if you just hear them for the first time in these particular terms. So yeah, don't feel bad. That's why we do these knowledge checks together. Oh my goodness, it's really fond of throwing them back to back. Which of the following is not a characteristic of threat hunting? Recursive, predominantly human-oriented, iterative, proactive. And I'm just going to give you guys the answer here. It's okay. I think that we've just had so many of them that it's just like, I'm just going to throw lots of stuff at you. So, and it had to do that to you guys right before the end of it too. So, okay, that's it for that particular one. The sessions are fairly short this week on there. Tomorrow, don't forget I have a doctor's appointment, so we may be running late for ours. But the nice thing is this week's lab, I'm going to be working with Kali Linux with you guys. So if you guys have any questions, stick around. Otherwise, I'm going to hit end.